by November 2026. Voyager 1 will have solidified its place as the farthest human-made object in the history of the universe. Floating 163 astronomical units from Earth more than 24 billion kilometers away, this lone warrior is still silently whispering its final breaths back home. But what few people know is that before it became a legend, it nearly became space junk back in 1977. The rocket engine cut off too early. Voyager was left with exactly 3.4 seconds of propellant to reach escape velocity. If those 3 seconds had been lost, the history of astronomy would have been erased. Its power, nothing more than a primitive 1970s brain. Its signal strength, a mere 23 watts dimmer than the light bulb in your bathroom. How does a frail bulb from the last century transmit data across billions of kilometers of void to speak with us? The answer lies in a physical paradox you're about to witness. When Voyager approached Jupiter, it plunged into a gravitational war zone. At a distance closer than the Moon is to Earth, the planet's gargantuan pull threatened to tear the craft apart. Yet in the heart of that madness, Voyager fired its cameras frantically. That was the moment we learned Jupiter too has rings. At Saturn, it discovered shepherd moons, 2 tiny satellites keeping the planet's magnificent rings in perfect order. Here, Voyager performed a brutal orbital maneuver, surrendering the rest of the solar system to Voyager 2 to embark on a journey with no return. And then on Valentine's Day 1990, it looked back one last time. One final photograph. A pale blue dot suspended in a veil of black velvet. The parting salute of an explorer slowly fading into the minus 240 degrees Celsius cold of the deep. One pale speck, photographed by a machine already 13 years old, running on a computer your smartwatch could defeat before breakfast. Now, the physics. Because this is what you actually came here for. Here is the brutal truth. 23 watts. 24 billion kilometers away. Physically speaking, we shouldn't be able to hear it. Look at the inverse square law. As Voyager's signal leaves the craft, it ripples out like a wave on a gargantuan lake. The further it travels, the thinner its energy is shredded. By the time it reaches Earth, its power density has withered to 10 to the power of negative 26 watts. An incomprehensible number. You would have to collect this signal continuously for billions of years just to gather enough energy to light a single LED for exactly 1 second. Essentially, NASA is trying to catch the sound of a single grain of sand falling in the middle of a cosmic electromagnetic storm. And yet we still hear it. Not by miracle, but through 2 marvels of engineering. Answer 1 Voyager does not shout in all directions. Its high-gain antenna, that distinctive white dish, focuses every watt into a beam so narrow it is essentially a laser of radio waves. All 23 watts are concentrated into a cone, tight enough that from 24 billion kilometers away, it is still aimed almost precisely at Earth. The engineers at JPL who calculated that antenna geometry in the 1970s using slide rules got the alignment right with a precision that still humbles the people who work with it today. Answer 2. The Deep Space Network. 3 antenna complexes. Goldstone in the California desert, Madrid in Spain, Canberra in Australia are spaced around the planet so that as Earth rotates, at least one dish is always facing Voyager. The largest antennas are 70 meters across. And to hear a signal this faint, the receivers must be cooled to within a few degrees of absolute zero, colder than interstellar space itself. The operators at those facilities, the engineers at DSN who maintain those systems, must eliminate every source of stray electromagnetic noise. The pointing must be accurate to fractions of a millidegree, and even then they are not receiving a signal in any conventional sense. They are conjuring one out of near nothingness, one photon at a time, using algorithms that extract coherent information from what looks to any ordinary instrument like pure background static. A 23-watt whisper, a 70-meter ear cooled to the edge of absolute zero. That is the conversation. But of course, everything has a margin of error. I'll bet that if you bring up Voyager, one half the people in the room would say, "Wait, I thought it went dark a long time ago." And honestly, they were right, but that was then. November 2023. And this is where the story shifts from epic to something far more intimate. The story of trying to save an old warrior that is dying 24 billion kilometers away, in silence and in the dark. The teams monitoring Voyager's telemetry at JPL noticed something wrong. The signal was still there, but what it was saying made no sense. The data stream had become corrupted, scrambled, and the spacecraft was transmitting something that looked like the output of a broken mind. Every command sent from Earth takes 23 hours to reach Voyager. Every response takes another 23 hours to return. Total 46 hours for a single exchange. Imagine trying to fix a dying computer in total darkness, but after every single key press, you have to wait nearly 2 full days just to see if it worked. It was a battle of wits in agonizing slow motion. Eventually, they found the culprit, a single corrupted chip inside the flight data system. A chip smaller than your thumbnail, but one that had been battered by 46 years of unrelenting cosmic ray bombardment. Irreplaceable, unreachable, sitting 24 billion kilometers away and still receding. So the engineers at JPL did something unprecedented in the history of space exploration. They scavenged through Voyager's ancient brain, searching for unused pockets of memory, scattered across other subsystems, empty spaces that had sat dormant for decades, as if they had been patiently waiting for this exact day. They shredded the corrupted code into fragments and tucked them into those tiny gaps. Think of it like trying to save a priceless manuscript from a burning library by tearing out every page and hiding them in the pockets of dozens of different people to carry them out safely. This wasn't just a software patch. It was a migration of the soul. By April 2024, after months of patient dialogue, across 24 billion kilometers, a void Voyager 1 was coherent again. Our legend had been resurrected. Then, in October 2024, a routine thermal command triggers an unexpected fault response. And Voyager, operating on protocols written before most of its caretakers were born, decides on its own. It shuts down its primary X-band transmitter, the modern communications channel, and powers on its S-band backup. A radio that had last been used in 1981. 43 years of silence, and it woke up and worked. The operators at the Deep Space Network facilities recalibrated their frozen receivers to the old frequency. They pointed their 70-meter dishes at a coordinate in interstellar space, and they heard it faint, ancient, unmistakable. The old warrior talking. Do you understand what that means? No modern spacecraft has a backup designed to wake up after 43 years of interstellar radiation. Voyager was built in an era that optimized for survival, not for quarterly budgets. Today, a 43-year redundancy wouldn't survive a spreadsheet. In 1977, it was the standard. One-word redundancy is what's saving us in 2024. But even this dialogue has an expiration date. Sometime in the early 2030s, the nuclear batteries will finally die. The transmitter will go silent. Not because we failed, but because physics patient and indifferent will finally collect its debt. And then something extraordinary happens. Voyager 1 will keep moving. With no friction to stop it, it will outlast every nation on Earth. It will outlast the word NASA. It will drift past stars and civilizations not yet born, carrying a golden record, a 12-inch message encoded with our music, our heartbeats, and our wind. It's not just science. It's a love letter written in the language of physics. It's our way of saying to the void, we were here. We were curious. We were not afraid. And that brings us to the end of today's exploration. Were you moved by the solitary yet glorious journey of Voyager 1? If so, please leave a small tribute in the comments for our distant friend. And if you have any wishes or insights, don't hesitate to share them, because who knows, they might just become the coordinates for our next destination. Keep your sensors open. Our journey continues.